Hello everyone, welcome to Mayu Programming Club. Today we will be solving another daily report challenge and the challenge name is sliding window maximum. So you are given an integer of nums. There is a sliding window of size k which is moving from very left of the array to the very right. So you can see only k numbers in the window. Each of the time the sliding window moves right by one position. Return the max sliding window. For example, here initially sliding window will be situated on this index and it will go till here. Now sliding window will be of size 3, which is the value of k. So it will be covering these elements. Now in these elements which the sliding window is currently covering, what is the maximum element here? It is 3. Now we will shift the sliding window to one position ahead and we will again check for the maximum element. It is 3. Now we will shift again to one position ahead and its maximum element will be 5 now. So now we continue on shifting and checking what is the maximum element and we will be returning a list of these maximum elements which is 3, 5, 5, 6, 7. You can also check this is the order indeed. So this is what you have to return. Now let's have a look at the constraints of the problem. Nth of nums array is of order 10 raised to power 5 and the values of nums array are in the range minus 10 raised to power 4 to 10 raised to power 4 and k's value lies between 1 to length of nums array. So how you will be solving this problem? Let's consider a brute force way to solve this problem first. Brute force way to solve this problem would be you will take the k size window starting from the very left. You will go till the right of the given array and when you are having for the current case size window you will check maximum. How you will be checking? You will be checking by iterating over this case size window once. Now how many such case size windows will be formed? The number of case size windows formed will be of order of length of given array, which is nothing but order of 10 raised to power 5. And what will be the maximum? What will be the maximum value of k possible? It is 10 raised to power 5. So in total, order of 10 raised to power 5 square operations will be required. These many number of operations will be required order of 10 raised to power 5 square for the brute force approach. Now 10 raised to power 5 square will be 10 raised to power 10, which is greater than 10 raised to power 8 operations. Allowed in 1 second. So for these number of operations, you will get a TLE. How I am checking 8 number of 10 raised to power 8 number of operations allowed in 1 second. Basically, if the number of operations of your program, these are the number of operations of the program of solution, exceeds or becomes equal to 10 raised to power 8 operations, then you may get a TLE and your solution will not be accepted. So in order to get those of you who are not familiar with this concept, I will be providing a link describing how the time complexity of a accepted solution varies according to input size. You can check this article out and then you will be able to understand what I am talking about here. Basically, you are allowed to do 10 raised, less than 10 raised to power 8 operations in program, and if your program reaches equal to those number of operations, then you may get a TLE. So ideally, you should be having less than 10 raised to power 8 operations in your program. So then you will get IAC. So to get IAC or accepted solution, you have to optimize the brute force. Where we can have optimizations, we can have optimization set for this iteration over array. We have to do because we have to move this window one step further uh, for the whole array from the very left to right. This we can't optimize. What we can optimize is we can optimize the iterating over the k size window once. Instead of iterating, what we will do is uh, let's consider this example only. And let's consider a sample input 1 3 minus 1 minus 3 5 3 6 7. Okay, now what will happen is, first of all, since the this queue, we will be considering this is as a W-ended queue. Those of you who are new to W-ended queue, I will be providing a link describing the W-ended queue. What it is essentially is, in a W-ended queue, insertion and deletion both are allowed at both ends. Allowed at both ends. So we will be inserting the values. What we will do is, essentially we will be maintaining a W-ended queue, and the numbers will be maintained in this order. This way, uh, it will be the smallest order, smallest number here, then the number greater than this, then the number greater than this. So this way it will be ascending order. Or you can say we will maintain the, from left to right, we will be maintaining a descending order in the given queue, W-ended queue. Maintain elements in queue in decreasing order. How you will be doing so? If let's say the queue is empty, then you cannot check for any element, whether it's greater or lesser. So what you will do is, you will put the element simply in the queue. Or let's move towards the coding section. There you will be able to understand in a clear way. Basically, basically you have to understand is, we will be maintaining elements in the queue in decreasing order, and we will not be storing elements. Instead of elements, we will storing their indices. Why we are storing their indices? Uh, to remove previous leftmost elements, yeah, for say indices, when the queue moves from left to right. So basically, when your queue will be situated here, then this index will be moved out of the queue, and these two indices will stay. The elements, let's say this is the first index, and this is the second index. These two will stay, and a new addition will be made, which is the third index. Zeroth index will be deleted from the queue. So, in order to facilitate this deletion of indices uh, for the previous elements, we will be using indices of the elements in the queue instead of the values of the elements. Because if let's say there are three threes present in the queue, then if let's say the queue's front is having three, then you will not be able to determine what is the index of three. I hope you are able to understand why we have taken the indices instead of the element values. So let's quickly move towards the coding part. There you will be able to understand it in a better way. What you have to keep in mind is, we are maintaining the order in the decreasing order of the element values. So the first index of the very, or you can say, let's say instead of decreasing order also, you can maintain the increasing order in the queue also. It is up to you, increasing or decreasing, whichever you may like. Let's continue with the increasing order. Basically, you have to just reverse your operations to maintain the elements in decreasing order, whichever order is of your preference. You can maintain in that order. So the first element will be the least element. It will be, let's say this is increasing order. Second element will be greater than this. The third will be the largest element. So let's quickly move towards the coding part. What we will do is we will Deque to store the indices of the elements in the given array. We are using indices to facilitate the removal of elements indices from the window as it moves from very left to very right of the given array. So this is the length of the given array. This is the result that we will be returning. What will the size of the result be? It will be nothing but size of the given input array minus k plus 1. You can check for some values, then you will be able to understand it is indeed the size will be this. You can check here also. So here the size is 6 and here the size was 3, 3, 6 and 2, 8. K was 3. So 3 minus 1 will be 2 and 8 minus 2 will be 6. So this is the answer, or you can say 8 minus 3 plus 1. This will be the same thing. So this is what the size of the result will be. And let's this index this pointer will be used to this pointer will be used to populate the result array. So what we will do is, let's say if the leftmost index in the window is no longer part of the window, which means window has moved one position ahead, then you will delete that leftmost index. Then you will delete that leftmost text to make room for the new index to be added in the window. So I hope you are able to understand what we are doing here. So then what you will do is fill the front of the current window is lesser. Fill the value at front index of current window is less than the current num. Then we will keep removing those elements, removing those indices. So essentially what you will do is, let's say your current window is like this, and your element to be added is the current window size was 4, let's say. So this is the window size allowed, and you were to add 3 in this window. So naturally this will be moving out. So what you will do is you will remove this one at this step. So now your window will be looking like this. Now you will be considering adding 3 to this window. Then what you will do is till the element at the front of this window is smaller than 3, you will be removing this element, and then you will be adding 3. Now the windows order in which the order is maintained will be increasing order. So in order to determine what is the maximum value in the current window, let me quickly change the color. You have to just look at the end of the Deque and return that. So this is what we are doing in this step, removing all the elements which are smaller than the current elements, all the indices of those elements. So at last you will add the index of the current element, add the index of the current element. Then what we will if let's say if the size of window is k currently, then you will start populating your result, and the number, the index of the number at the last of the window, at the end of the window, will be maximum will be maximum. So this will be the maximum value in the current window. You will be adding that result, and you will be implementing your pointer that is helping us to populate the values, populate the result array, and at last you will return the results array. So this is how you will be solving this problem. We have done some. Okay, while commenting, we commented this semicolon also. We have to place it here. So as you can see, the solution is getting accepted. So this is how you will be solving the problem. And what will be the time complexity and space complexities? Your time complexity will be nothing but size of your input array, order of size of your input array, and your space complexity will be order of maximum value possible for, or you can say order of k, whichever the value of k will be given in input, it will be that to store the to store the elements in the window. So indices of element window. So these will be the complexities, time complexity and space complexity. And since maximum size of input array was 10 raised to power 5, it is lesser than 10 raised to power 8 operations. So your solution will be accepted. And if you are still having any doubts, please feel free to ask them in the comment section. Thank you for watching. Thanks.